What does vertical bar equals IA do in Python? Google won't let me search vertical bar equals, so I'm having trouble finding relevant documentation. Anybody know?
Vertical bar equals performs an in-place plus operation between pairs of objects. In particular, between sets, a union operation, dicts, an update operation, counters, a union of multisets, operation, numbers, a bitwise or binary operation. In most cases, it is related to the operator. See examples below. Sets. For example, the union of two sets assigned to S1 and S2 share the following equivalent expressions. Where the final value of S1 is equivalent either by an assigned or operation, an in-place or operation, an in-place or operation via special method ++. Example. Here we apply OR, vertical bar, and the in-place OR, vertical bar equals, to sets. Dictionaries. In Python 3.9+, new merge, vertical bar, and update, vertical bar equals, operators are proposed between dictionaries. Note, these are not the same as set operators mentioned above. Given operations between two dicts assigned to D1 and D2. Where D1 is equivalent via an assigned merge right operation, an in-place merge right, update operation, equivalent to D1.update D2. Example. Here we apply merge, vertical bar, and update, vertical bar equals to dicts. Counters. The collections.counter is related to a mathematical data structure called a multiset set. It is basically a dict of object multiplicity key-value pairs. Given operations between two counters assigned to C1 and C2. Where C1 is equivalent via an assigned union operation, an in-place union operation, a union of multisets contains the maximum multiplicities per entry. Note, this does not behave the same way as between two sets or between two regular dicts. Example. Here we apply union, vertical bar, and the in-place union, vertical bar equals to counters. Numbers. Lastly, you can do binary math. Given operations between two numbers assigned to N1 and N2. Where N1 is equivalent via an assigned bitwise or operation, an in-place bitwise or operation. Example. Here we apply bitwise or vertical bar, and the in-place bitwise or vertical bar equals to numbers. Review. This section briefly reviews some bitwise math. In the simplest case, the bitwise or operation compares two binary bits. It will always return 1 except when both bits are 0. We now extend this idea beyond binary numbers. Given any two integral numbers, lacking fractional components, we apply the bitwise OR and get an integral result. How? In general, the bitwise operations follow some rules. Internally compare binary equivalents, apply the operation, return the result as the given type. Let's apply these rules to our regular integers above. 1. Compare binary equivalents, seen here as strings. 0b denotes binary. 2. Apply a bitwise OR operation to each column. 0 when both are 0, else 1. 3. Return the result in the given type, for example base 10, decimal. The internal binary comparison means we can apply the latter to integers in any base, for example hex and octal. See also an example of overloading the _ir_ method to iterate iterables in a new table set abstract base class. Hettinger's ordered set recipe. See lines 3 and 10 respectively. A thread on Python ideas on why to use vertical bar equals to update a set. A section B.8 of dive in Python 3 on special methods of Python operators. In place binary operators fall back to regular methods. See Python source code. eval.c and abstract.c. Thanks Aristotle. A post on how Python handles displaying prepended zeros in bitwise computations. Plus the in-place bitwise OR operator cannot be applied to literals, assign objects to names. Plus special methods return the same operations as their corresponding operators.
In Python, and many other programming languages, is the bitwise OR operation. Vertical bar equals is to, as plus equals is to plus, i.e. a combination of operation and assignment. So var vertical bar equals value is short for var equals var, value. A common use case is to merge two sets.
When used with sets, it performs union operation.
This is just an OR operation between the current variable and the other one. Being t equals true and f equals false, see the output graphically. For example,